This is lesson 7.2, simplifying expressions. The distributive property can be used to simplify a variable expression. When you have 2x plus 3x, you can put 2 plus 3 in parentheses times the x using distributive property. Then you just add the 2 and the 3 and you get 5 times the x, which is again is 5x. So that 5x would be your simplified expression of 2x plus 3x. The parts of an expression that are being added together, such as 2x and 3x in the expression 2x plus 3x, are called terms. Terms that have identical variable parts are called like terms. So 2x plus 3x would be like terms. In the expression 2x plus 3x, 2x and 3x are like terms. The distributive property allows you to combine like terms. Okay? In a term that is the product of a number and a variable, the number in front of the variable is called the coefficient of the variable. A term that has a number but no variable is a constant term. That's just a number by itself. In the expression 4a plus 1, 4, which is attached to the variable, is your coefficient, and then 1 would be your constant because it's by itself. So an example, we're going to identify the coefficients, the constant terms, and like terms of the expression x plus 4 minus 2x minus 10. The very first thing you have to do is make this an addition problem, or write it as a sum. So it end up being x plus 4 plus a negative 2x plus a negative 10. Now again, you're going to have to know your integer operation rules to be able to do these type problems. So once we do that, now we can identify the coefficients, the constant terms, and like terms. First, the coefficients. Again, they are the numbers attached to the variable. So x by itself, it's understood it's got a 1 in front of it. X is the same as 1 times x. So the coefficient for x would be 1. The coefficient for negative 2x would be negative 2. So the coefficients are 1 and negative 2. The constant terms, again, are 4 and negative 10 in this case, because they are the numbers by themselves. Then we want to identify the like terms. So the like terms are x and negative 2x, because they both have variables. And then constants by themselves are like terms if there's more than one of those. So in this case, there are 4 and negative 10 are like terms. Here's an example. So we want to identify the coefficients, the constant terms, and like terms of the expression, then simplify the expression. So again, the first thing you have to do is make this an addition problem. So it's going to be 16, oops, here we go, 16 plus a negative 8k plus 9k plus a negative 8. So again, if it's subtraction, you changed it to addition and switch the sign of the second integer. Same way here. You switch this to addition and change the sign of the second integer. So now we can identify the parts of this. First, we're going to identify the coefficients. The coefficients, again, are the numbers that are attached to the variable. Here you have a negative 8, and here you have a 9. So those are your coefficients. Then your constant terms, again, are the numbers by themselves. You have a 16 and a negative 8. Then we want to identify like terms. So our like terms are negative 8k and 9k are like terms. And then our constants, 16 and negative 8, are like terms. So from this problem we've identified, again, the first step is to make it an addition problem or a sum. Identify the coefficient, the constant term, and the like terms. Alright, simplifying expressions. You have 5 and then times w minus 4 in parentheses plus w plus 8. First thing you have to do is use distributive property. Here, we're going to multiply 5 times w and get 5w minus 5 times 4 is 20. So now you have 5w minus 20 plus w plus 8. Then the next step is to write it as a sum. So that would be 5w plus a negative 20 plus w plus 8. Then we use commutative property to reorder here. Put our coefficients and variables together, and then our constants together. So you have 5w plus a negative 20 plus 8. combine like terms, which are here and here. So combine these two like terms. 5w plus 1w is 6w. Then you've got negative 20 plus 8. The signs are different. So you subtract and keep the sign of the larger number. Subtract, you get 12, and 20 is bigger than 8, and it's negative, so negative 12. So you end up with 6w plus the negative 12. Simplify it even further, you can just make this subtraction, 6w minus 12. I would take either one of these answers here, it would probably be fine. Another type of example is a rectangular exercise mat is twice as long as it is wide. Write and simplify an expression for the perimeter of the mat in terms of the width w. So again, the width is w, and you know that the length is twice that, so that would be 2w for the length. Using perimeter, the formula for perimeter is 2 times the length plus 2 times the width. So substituting in, the length again is 2w, so it would be 2 times 2w plus 2 times the width, which is w. So multiply here, 2 times 2w is 4w plus 2w, which ends up being 6w simplified. So the simplified version would be of this formula would be 6w. An expression for the perimeter of the mat is 6w. So let's actually work out an example here. It says a rectangle is 6 inches longer than it is wide. Write and simplify an expression for the perimeter of the rectangle in terms of the width w. So again, our width is w, and then our length is 6 inches longer than that, so it would be w plus 6. Alright, our formula for perimeter again is p equals 2 times the length plus 2 times the width. Substitute in 2 times the length. Length is w plus 6 plus 2w. Again, using distributive property, 2 times w is 2w plus 2 times 6 is 12 plus 2w. Using commutative property, reorder, 2w plus 2w plus 12. And then our answer would be 2w plus 2w is 4w plus 12 is our simplified answer. So the expression for the perimeter of this rectangle would be 4w plus 12. And we'll conclude on a simplifying combine like terms to simplify the expression. So again, it has to be a sum, so let's make this a sum. That's a negative p plus 3 plus 2.4p plus a negative 2p. Now we have an addition problem. So now we can simplify, so let's use commutative property to reorder. So we end up negative p plus 2.4p plus a negative 2p plus 3. Let's combine what we know. We got a negative 1 and a negative 2p makes negative 3p plus 2.4p plus 3. Negative 3 plus 2.4p. Signs are different, so you subtract. So it's 3.0 minus 2.4 is 0.6. So you end up with 0.6 and negative 0.6p plus 3. So here's your simplified expression for this problem. So this concludes our lesson on simplifying expressions.